Hi folks, welcome back to Physics with Captain Rod. We're going to chat about 16 and 18 in 2-2. So 16, it says something about an athlete leaping straight up in the air from a trampoline or something. So start with a picture. And we got the ground and maybe this trampoline thing. Your pictures don't have to be that elaborate. We have this person who is leaping. This picture here, though, here's kind of important to realize. This is going to be, there's a little bit of daylight there. Right when they left the trampoline, they're on their way up. They've got some sort of velocity given in the problem. I would like to point out because it says at a speed at. Let's put a 1 on it or something. And then it says something about, let's see, the goal is to find her maximum height and her speed at half the maximum height. So let's say here's a second picture, distance kind of exaggerated, where she's at half the maximum height. Put h max over 2. Let's call this like picture 2 maybe. And then here's 3 at a maximum possible height. And it's completely okay to exaggerate these distances. The person's probably not going to fly 25 feet in the air. But so in our picture here, definitely they've got a speed at V1. Also, there's a speed here at V2, or in picture 2, we should call that something like V2. But at the highest point, they're V3, probably about 0. I say about because maybe they've got a small horizontal velocity component, but not important for the question. So I think I'd start by focusing on 1 to 3. To find that maximum height, because if you focus from 1 to 2, you're not going to know the height or the velocity, so that's going to have 2 unknowns. So go ahead and write out the work energy theorem. PE1 plus KE1 plus work equals PE3 plus KE3. You're wondering, maybe can I go from 1 to 3? Heck yes, these are just labels. You can write them there from no problem at all. It says in the problem to select this height as your datum. So that's going to force your PE1 to 0. You're going to have a KE1. You're going to have a PE3, but no KE3. And the work term also will be 0, and here's why. So that person, I try to make a big deal of this, while they're on their way up, the gravitational force is down, and it does in fact do work. So, you imagine this person starting here, force times distance, there is work done. But if you use potential energies, that's what you're taking into account. So, in fact, imagine had you never heard of the term potential energy. The work done by gravity, going from 1 to 3, would be minus mgh. Minus because the force is down, but the motion is up. Putting a minus mgh right here is the same as putting a positive mgh over on the right hand side. So generally speaking, we save work terms for non-conservative forces and use potential energies for the gravitational force. So write that equation out. Again, I'll kind of overview it here for you. You'll have a 0 here, you'll have a number here, a 0, an mgh, and a 1/2 mv squared. And that velocity is velocity 3. Oh, at the highest point, though, that should be 0. That should allow you to calculate the max height from here. Okay, next part, write the work energy theorem out again from 1 to 2. And again, this will be 0. You'll have a number. You can put 1/2 mv squared here. I'll just put like a number here. You'll have that. Just like before, we're going to use potential energies for the work term. Here at 2, you will have a potential energy, an mg times h over 2. And you will also have a kinetic energy of 1/2 mv squared. So that should get you through that problem without issue. Let's chat about 18. Okay, we got this daredevil dude. Let me start by updating my picture. So we got this motorcycle. And here's my, super duper quick sketch of the motorcycle guy. Got this guy riding the bike here. Your sketches don't have to be great. This is good enough. Sorry, I know that really is horrible, but all right, at the instance shown, they've got a velocity, probably maybe we call that velocity 1. Then the motorcycle's up here somewhere. It looks like, you know, in the picture it's probably leveled off. Whether it has or not important. I don't know. Here's our riding dude. Wow, really crummy photo, but... And they've got some sort of velocity. Let's call this position 2. So we've got a V1 and a V2. So go ahead and write out the work energy theorem. Your PE1 plus KE1 plus work equals PE2 plus KE2. I would datum it right here, making your PE1 term 0. But you will have a KE1, that's a number given in the problem. Under position 2, you're going to have a KE2, that number given in the problem, but also a PE2 and MGH. That should get you through 18. So hope that this helps. Have a great day. Make sure your pictures are better than mine.